usually what I do for my company is to actually build stuff. So a lot of what I will be talking about are a lot of the application architectures that have come out of the projects that I've been on while working at here at Headspring. So first, before we get into vertical slice architecture, I want to have a little bit of a history lesson. This is someone that lost some battle. He's not an American because we don't lose battles, I think. At least we don't teach about the ones we lose. So I want to talk about some of the losing architectures that I've used over the years. And the big one that I've seen a lot is this in-tier style architecture, where you organize your application's code into these very well-defined tiers in your application. And the general idea is that no one tier can directly reference the other or something like that. So your UI layer can talk to the business logic layer, but the business logic layer doesn't talk to the UI layer directly. There's probably some kind of data access layer using some kind of ORM, and of course, eventually we go into a database. Most of the application architectures I see are just some variant of this kind of style. They'll switch out names of things. So like instead of business logic layer, you'll have domain layer. Instead of data access layer, you'll have the ORM. But otherwise, it pretty much follows this pattern of you have these very well-defined strata or tiers in your architecture. And you have this very hard-defined separation between each of these layers. And so typically the code in your application in this kind of architecture, you'd organize that code by each individual layer. So you'd have some kind of UI layer, so that'd be some kind of controller, so you'd have the person controller. The business logic, of course, we can't put in the UI layer, so we'd put that business logic into a service, so we'd have some kind of person service, if this is based on person. And then finally, any kind of data access logic, we don't want to use directly, of course, because just in case we change databases, because we do that all the time, right? Like we just switch between SQL Server and Oracle and then document databases, like that's what people do, right? No, of course not, but we have this application architecture just assuming that maybe that will happen someday. So when you start to organize your code like this, I found that it becomes pretty difficult to understand what's actually going on in your system. Typically because our code is organized around each of these different layers. So we have the controllers of our application in a controllers folder. Any kind of handling logic, we have handlers. If we have things we show on the screen, we have a view models folder, and then finally the actual HTML we're showing to the end user is in our views. So whenever I want to change something in this application, I have to go to all these different places, and I can't really understand how everything all comes together. So this talk is a bit of a sequel to a talk I did a couple years ago called Solid Architecture and Slices, Not Layers. So I want to really dig deep into what it looks like in an application when we get rid of all of these complicated layers and start to organize our application instead around the axes of change. And so that's what vertical slice architecture really is. It's where we model and organize our application architecture instead of the types of things they are. Instead, we model and organize around the axes of change. So things that change together belong together. And each of these areas of change, I call a vertical slice. So what does that vertical slice look like? Well, the first thing we want to do whenever we're building out one of these vertical slices is take all that disparate code we found in a lot of different places and move it into one single place. So that I have to make some change to the system along one single axis of change, then I only have to go to one spot in my code base where all that relevant code lives. So typically on our a domain-driven design application, we have a lot of these kind of service classes. And so when we're building in these this architectural style of vertical slices, what we'll be doing is taking all of those disparate methods that really don't have anything to do with each other and moving each of that logic into its own individual class or type so that all of the code and logic associated with each one of those different methods isn't in some kind of God service class that has nothing to do with each other. Instead, each of those sets of operations is in its own class and its own type, completely separated from any of the other ones. Now, as we start to go down this path of moving each of these methods into their own types, we start to notice some patterns emerge. And that our application now has these very distinct types that represent individual things you can do in the application. And so what we start to do is model our application around each of these kinds of requests. So you can think about all the different things you can do in your application, like all the different buttons, all the different screens. Each of those is some kind of distinct request to either do something or get some information back out. And so I model all of this information into a series of requests. So I have some kind of input that is then taken by some kind of handler for that request, and that produces some kind of output. I know it's like the stupidest thing that could possibly work, but that's really what we were trying to go for here. Now, I started doing this on lots of different applications, and I got to the point where I was copying this kind of boilerplate code to do this kind of thing in all my systems. So eventually my boss was like, Jimmy, can you just please make an open source project of this because you're copying the same stupid code over and over again? And so that's what I did with my mediator project, is encapsulating this kind of architecture into something that was really sort of simple to use. So in this kind of system, we have our requests modeled as some kind of request object. In this case, it implements an interface of iRequest of t, so I know what the return type is, that t return type. And then I have some kind of class that implements a request handler. And that request handler just has one single method, handle. You pass in the request, and it returns whatever that return response is. And so I have this encapsulated request, something that handles the request, and then finally some kind of response on the other side. Now, I will warn you, if you're using functional languages, like most of what you see today is just out of the box with those. But we're using C#, which isn't really a functional language. We can try to pretend like it is sometimes, but it gets really, really ugly. So if you want to use this style to its fullest, then you really need to start looking at those functional style languages because they support these kinds of structures out of the box really well. We're in C#, though. It doesn't support those kind of things super easily, so we'll have to build classes to represent this function of handle this request and return some kind of response. And of course, everything is async these days, right? Like we can't do anything with something be async, so this class returns a task as opposed to just that object directly. Now I wanted to make my easy for myself, so to just register this, I'm using, this is ASP.NET Core, that's probably not that exciting. But I wanted to make sure that I could easily discover all the different handlers in my application. And so that one line we have right there that says add mediator, where I'm giving it some kind of type to go search the assembly for those handlers, that's all I have to do to be able to register all of the different handlers in my system. So there's not some kind of explicit registration where every single time I have a new handler, I have to do something. Instead, this scans everything and wires up everything for me. So in my systems, typically I have just two basic kinds of requests. And so for a web application, that basically boils down to gets and posts. That is, I'm getting some information out of the system, or I'm performing some kind of query, or I'm posting to be able to affect some kind of change in my in the back end. So for queries, these are again modeled as requests. But this time the request is not some generic request. My request is an actual query object. So in this case, I have some kind of type that represents that distinct query that is passed to a handler. And then finally, the response is the output of that query. And then on the post side, it's very similar, except this time I'm modeling it as a command. So I have some kind of command that goes into the system. Something handles that command. And then finally, out the other side comes a response. So this right here is the CQRS pattern at its most basic implementation, where I've taken my original object that was like all the services and stuff that wired everything together. Instead, I'm separating out my application into a series of queries to be able to get information and commands to be able to do something with the application. Now, one of the things that's really important with this kind of architecture is to make sure that we don't try to overlap a lot of the concepts. So one of the things we really try to focus on is making sure that everything required to process the request is encapsulated in those initial request objects. And we have one model going into this handler and then one model coming out the other side. So whatever it needs to do to be able to perform whatever operation it's doing, that's all captured in those request objects and the queries and the commands. And then whatever comes out the other side is then finally captured in that response. And I want to have complete encapsulation of whatever is going on behind the scenes. So from the application perspective, all it knows about is these requests and responses, and it doesn't concern itself with the details of exactly what's going on behind the scenes. So all that code that was required to do whatever work was necessary, I'm pushing it inside of the handler so that the application doesn't know or care about what exactly is going on behind the scenes. It just knows, here's this request, and then finally out the other side comes a response. So when we go down this route, we start to have to worry about, well, now that I have these requests and responses, what should these queries look like? So the very simple version of this could just be an empty type. So in this case, I have a query that represents showing some information on an index page. But one of the things I'm trying to do here is make sure that I'm not, I capture that distinct kind of request. In this case, I'm using a type in order to capture that. So in this case, I have a query object that is nested under the index class so that I know that this query is different and separate than any other query in my system. And so I'm trying to make sure that if I have to change this query, I don't have to worry about changing any other query in my system. And all the parameters or anything I need to do for this is encapsulated in this one class. I'm not trying to share it with anything else. Now, if I do have additional information for queries, typically if I have parameters associated with my query, in that case, then what I'll do is just take all the inputs that the query handler needs and just have them encapsulated as properties on that query. So it's just all the data that the query handler needs to be able to perform that operation, I capture on parameters in this query object. Now things can get complicated for queries. Like if I have some like complicated page that does things like paging and sorting and filtering, again, these are just additional properties I put on top of this query object. Now you notice the query is just like a very simple class. There's no additional dependencies or anything like that. This is just meant to represent the request to be able to get some information out, and then all the information that handler needs to be able to get that information, whatever the query is then doing. Now, the responses on the other side are, again, whatever information I need to actually then go do whatever the work is necessary to give that information back to the end user. So I do have to know like what exactly the response is being used for. So if the response is being used to display HTML, then it's probably just going to be the data being bound to the screen. But if it's something like a REST, hypermedia, really complicated response, then again, that response would then be whatever data is necessary to build out whatever response is coming out the other side. So a simple one is just showing some data on a screen. And so in this response, I'm just capturing all the data that is going to be displayed on that screen and representing this as a very simple class here. Now this class is not connected to anything. So you can take this class and it's not like persisted in the database or anything like that. It's just a very simple data transfer object or DTO. I try to keep things as very simple and lightweight as possible. So this data that I'm putting in this response is only the data that's being shown on the screen and nothing else. So basically looking at all the fields on the screen, I'm building up this object to say these are only the fields that I'm going to be taking and then handing it back to the end user either through HTML or JSON or whatever it might be. This is only the information that I need back from that response. Now things can get more complicated. So in this case, I've got kind of a nested list of objects here. So I have like, this could be like a master detail kind of view of some information. So in this case, I have the simple properties, but then if I have to show some more complex objects, instead of me using that like maybe ORM, data bound, whatever thing behind the scenes, instead what I'm doing is just capturing, again, the information I'm showing for that screen, and then representing that as a type that is then nested under my parent response type. So the idea is that this response, if I need to change it, I don't affect any other response in my system. Everything I need is in this response, and if it needs to change, I don't have to worry about stepping on any other handler or any other responses in my system. Now, very often, I'll have a lot of commands and queries that tend to go with each other. So you can imagine a web page where you're going to look at some information and then you go to edit that information. Well, when you click that edit link or that edit button, you're still shown some information on the screen. So that is still getting data back out to be able to be shown in a form. So very often what I'll have is a query that is then returning the actual command, and then the command is what then the user posts back up through HTTP. So in this case, my command, my query returns a command, and then my command is also a request to then go change that information as well. So most of the forms in my application have this kind of duality of a query that returns a command, and then the command that then goes and gets posted back up to actually do something in the system. So let's look at what those commands could look like. The simplest of commands doesn't necessarily return anything. So in this case, my command just implements this iRequest interface with no return type because it could just be kind of a fire and forget, like just do this thing, but I don't need to like get any response back from the other side. Now the information in this command is again only the information that is necessary to handle this request and nothing else. So I figure out what all the logic is necessary to be able to handle this command, and that information that's needed to handle that request is then only the information I put into this individual command. So typically, for something like a web form, I'm looking at the screen and saying, OK, here's all the form fields I have on the screen. I'm representing all those form fields as properties then on my request object. This works really well when I start to do more task-based user interfaces. And most of the UIs that we build have this kind of style that I'm not doing basic CRUD kind of operations. I instead have individual tasks that the user can perform. So instead of something like edit a user, update a user, things like that, instead I look at the individual actions the user is trying to perform and represent those as different actions in the user interface. So in this case, the student, I can do different things with them. I can transfer the student, maybe from one school to another. I can correct some of their information, or I can change something of their schedule. Now, all of these things are kind of editing student information, but they're really different operations that probably have different business rules, business logic, validation, things like that. So I'm representing those as individual things, actions the user can do with the web page. And then each of those different tasks can then be represented as each of these individual requests with separated code, handlers, requests, and responses behind the scenes. So transfer, that individual request, has its own transfer request, handler, response. Correcting a user's information or a student's information has its own request, handler, and response. And the same thing with scheduling. And one thing you'll notice here is that none of the different requests, handlers, or responses are going to be shared between each of these different handlers. So if something needs to change in one of these different handlers, I don't have to worry about affecting anything else in the rest of my system. Now, one of the really great things we found about this is for systems and applications like this, my team itself, they're typically only ever adding code to my system. They're not usually changing existing code. And that's a great place to be in. If I'm only ever adding code, I don't have to worry about breaking other parts of the system because I'm not changing, potentially breaking some behavior that's going on behind the scenes. So in this case, the application could have just started out with just showing student details. Now I have a user story that comes along and says, now I need to be able to transfer that student. And so when I'm doing that, when I'm coding that part of the system, I'm only adding the transfer request, the handler, and the response. I don't have to worry about affecting anything else. So as new user stories come in for each of these different actions the user can perform, the developers are only ever adding code to the system. That's like 99% of the time. Of course, there are cases where we would have to change something with their system. But if I have to change something, I only worry about what's going on with this one request. I only have to worry about the logic of this one flow. I don't have to worry about the logic of any of the other flows. Now going down the rabbit hole again with the responses of commands, again, these can be fairly simple. Like maybe there is no response whatsoever for a command. I'm just saying do this thing, but I don't really expect any kind of response. Now in .NET, we don't have like a void type. So in my case, I typically make up or borrow the F# unit type to say this is still some kind of response, but you don't care about it. But for most of my commands, there is no response. It do the thing, and if it's good, then we're good. Sometimes I do have a response, and usually this is in the case of if I have some kind of validation or I need to know the output or the outcome of trying to perform that request. So it could be something very simple like, did it succeed or did it fail? So in that case, my command is a request that returns a Boolean, and that Boolean represents the success or failure of being able to perform that operation. Or it could get more complicated, like let's say I'm creating something. So the response type is going to be perhaps the ID of the entity created. So in this case, the request is a request of GUID. And then on the output of the other side, it is whatever the ID of the thing that's created. And then perhaps that then gets sent to the end user as some kind of redirect to say, OK, you've created this thing, and now I'll redirect you to the page of the thing that you just created. Now, it can get pretty complicated, so some of our more complicated projects have much more complicated result types. So in this case, I've got a more complex command result from all of my different command handlers. And this encapsulates not only the success failure, but it can also have a failure reason, as well as being able to represent some kind of potential payload of doing that operation. So maybe it's like, maybe it's the actual object that was created or affected, but it also includes the success failure reasons or the failure reasons in case something goes wrong. Now, finally, the more interesting part, like it's pretty simple to model the requests and responses. They're just dumb objects that have only the information necessary to be able to handle that request or return the response. Where things start to get interesting is now the code that I have inside each of my handlers. Now, on the query side, most of my queries are very, very simple. They're just really like, what is the simplest way possible I can be able to query whatever information store I have and return that information out to the end user. So most of ours are doing something like, yes, I have to plug this sometime because it's my project, I have to. Sometimes, or most of the time, we used a simple AutoMapper projection. So what this is doing for us behind the scenes is it's using the entity framework or whatever ORM's link query provider. And that one line right there that says project to, it translates the projection information from AutoMapper into a link select projection. And then that select projection is passed through to the ORM, which then crafts the SQL only necessary to be able to output whatever that model is. So this is basically, if you can think like like a SQL view, that one project to line is basically a dynamic output of a SQL view, basically. By the way, if you get one thing away from this and you use, if you use AutoMapper and you get one thing out of this, it's to use that as much as possible because that results in very efficient querying to the database that you don't have to worry about any kind of crazy ORM stuff. So if you get one thing out of that, it's to use project to as much as possible. Or we can just use straight up SQL. So in this case, again, I'm using, I don't know, whatever ORM this is. And inside the query handler is whatever SQL is necessary to be able to perform that operation. So in this case, I'm just hard coding SQL. This could be using a store procedure if we were forced to, or just whatever SQL is necessary to be able to do whatever the query task this is supposed to do. So what this winds up doing is encapsulating all of the logic to be able to perform whatever the query is inside of the handler. So from the application's perspective, it doesn't know or care exactly the implementation details of whatever the handler is doing. So if it's using EF core to be able to take that query and get the response, OK. Or it could be using some kind of like micro ORM that's very SQL friendly. It could be calling out to some other API, or just like whatever is doing it. I don't really care because all my application sees is a query, then sending it out to the handler, and then getting some kind of response. The actual work being done is 100% encapsulated behind that handler. Now, there are cases where we do have some duplication between handlers, and this is where it starts to rely on us as developers to be able to recognize these kind of scenarios and then make a decision about what's the best way to handle whatever kind of duplication I'm seeing behind the scenes here. So if I have two different handlers that have some kind of common logic for me, in this case, I start to make a decision of, well, what is that duplicate logic? Is it actually duplicate, or is it just look the same and it's kind of accidental duplication, but it's not actual real duplication of common logic? So for those cases, I have to look at, well, what's the best way for me to pull that common logic out? I could put it in a separate class. I can put it in a function, extension method. It's really up to me exactly how I decide to pull out that common logic. I will say for queries, it doesn't really come up that much. Like I don't really have a lot of common logic between different queries in my application because typically those screens are going to be very, very different. If there is common queries, it's usually because there's like common UI elements that are shown on every single screen. And so typically I represent those as individual distinct handlers to begin with. Now on the command handler side, this is where I like to make things as absolutely brain dead and stupid as possible. So the advice we typically give our developers is just make the most boring thing that could possibly work. And then if it starts to become more complicated, then we can refactor from there. But just like hard code everything, just to do the stupidest thing that can possibly work. Don't worry about any kind of abstractions or anything like that. Just put the code like directly into that method there. So in this case, I've got like just the most dumb procedural logic I could possibly imagine to be able to handle, in this case, updating some course information, I guess. So I said, well, what's the stupidest thing that could possibly work? And if that code looks OK, then I just stop right here. I don't have to really go any farther. There's nothing really to refactor here, or like just the stupidest thing that could possibly work. Now, one thing I do make sure that we do is, in this, because we're using C# and it's an object-oriented language that typically forces us down a path of using dependency injection. We can look at this and say, well, if this thing has other dependencies needed to do its work, I could pass those in via method arguments. We've gone down that route, and it starts to become really ugly really fast because C# just doesn't, it just doesn't want you to go that direction. So we'll still use dependency injection, but we won't put any abstractions in place. So if you need some kind of dependency, you just use that dependency directly. So in this case, I'm using entity framework something or other and AutoMapper. So I'm saying just use those things directly. Don't put any of these behind any kind of abstraction, any kind of anything like that. Just use those dependencies directly. Now, I have had to actually replace dependencies in applications. So like I was using entity framework and we switched to some other method. I will say that trying to abstract them actually makes those kinds of changes much, much more difficult. In this style of architecture, where I have every single request encapsulated in its own handler, if I need a change from one dependency to another, I can do that in a much safer manner because I'm only affecting one handler at a time. So I can, for example, I'm moving from entity framework to I don't know, Dapper or something like that. I can do it just one handler at a time and convert each of those handlers, get it working, and move on to the next one. So by basically hard coding it into the whatever dependency I need, it actually makes it easier to change because I've encapsulated all the logic into these individual handlers. So don't panic. You will have, code will get ugly in these handlers, but that's OK. Because we can still fall back to that old red-green refactor stuff that we don't really do anymore, right? Does anyone actually still do TDD? Actually still do it? Wait, you do R. You can't TDD R. OK. So we can fall back on these kind of tried and true methods of write the dumbest code that could possibly work, get the test passing, and once we have something that works, take a step back and say, OK, how can we make this code cleaner? So for these cases, I actually fall back onto those refactoring books that I don't think many people read anymore, but I find them extremely valuable. So I start to look at the code smells that emerge out of my handlers to say, now that I've had all my logic encapsulated in this one spot, take a step back to see if it exhibits any of the kind of common code smells. Now in this refactoring book, there's I don't know, 3 or 4 dozen different code smells that are in there. I focus on the ones that just concern handlers. So they're basically my class got too big, or the method got too long. And once I understand that this is too big or too long, then I start to look at, okay, what are the appropriate refactorings based on the logic that I'm seeing there? So from there, it's kind of like a recipe book that says, well, maybe this will work. Maybe I can use the compose method to break that one method into a bunch of smaller methods to make it more easier to understand. I don't have to go with any one of these. I could say, well, it's long, but I understand it, so it's OK. It just lets me decide, well, based on what I'm seeing here, what is the most appropriate refactoring from what I see? I still do use design patterns every now and again, mainly because the design patterns are I find in C# are meant to work around limitations of the language. If I use another language, then these kind of patterns I wouldn't need to put in place. So for me, I still use patterns in the case of needing to refactor my code. So typically, I run into these in some kind of behavioral spell, where things like I've got too many if statements, or I've got a lot of conditional complexity, or I've got one code over here that's dealing with a lot of code over here, so maybe I need to move that code around. So for this, I actually rely on another book called Refactoring to Patterns, which is, to me, the better pattern book, because it talks about looking at code that exhibits these smells and say, instead of you just coming out of the gate with some kind of pattern in place, wait till you have all the code written and then take a step back and say, is there a pattern that can help improve the understandability or the maintainability of this code? So I use this Refactoring to Patterns book based on different code smells, and then from there decide, OK, what pattern is most appropriate for whatever I'm seeing going on here. But most of the time, the kind of refactoring I do is to try to push the behavior down into the domain model of my application. So in this case, I've got a handler that's doing some stuff with data access. So basically, the first 10 lines or so are just data access code. And then the most interesting part is down at the bottom, which just says instructor.handle, and then it's passing in the message and the whatever object it needs to do to be able to perform that action. So instead of me doing all of the work inside of my handler, I'm pushing that down into the domain so the domain can do all of the work itself. So I'm taking that code and just moving it into the domain so the domain performs most of the logic, and then the domain itself is encapsulated from all the other stuff in my system. So I only have to worry about if this domain logic needs to change, I'm only really affecting this one individual request. Now, one of the things that comes up very often when I have this style of application is to try to look at, well, okay, I can perform all these requests, but I also need to do some kind of validation of these requests. And I found that this vertical slice architecture actually fits really well with encapsulated validation as well. Now, validation in my systems typically has a couple different scopes. Usually there's the just bare bones request validation. You can kind of imagine this like if you go to a doctor or have to fill out some kind of government application, that it's just a form with all the different fields on it. And when you hand it to the person, all they're doing initially is just making sure you filled out everything. So that's what really the request validation is just to make sure that like no one just, like it wasn't my cat walking on the laptop keyboard. Like all the stuff is filled in and all the, at least like data types are correct. Now from there, there's usually some kind of more complex validation that needs to happen. So in that more complex validation, I'm not necessarily just looking at the request itself, but perhaps having to go out to other things, other pieces of information. So in that case, I'm looking at more kind of command validation. Not just is the request filled out, but now based on the state of my system, is it valid to do this thing? Now request validation, we can use, in this case, this is a framework called Fluent Validation that has this concept like of a validator of T. And because my T are these request types, it actually works really well with this third-party library. So in this case, I have my validation logic and rules as this kind of Fluent syntax. But if I wanted to use like any of the validation frameworks out there, really my validation, instead of centering around the domain, it instead centers around these individual requests. Because then I'm not validating the domain, I'm validating just the request by itself. My domain validation can be more complicated. So in this case, I'm approving an order. So in this case, I have to look at the state of the order to say, is it valid to be able to perform this operation? So if the status was rejected, if I've already rejected this order, well, I can't approve this order. So then in that case, I return back a failure result saying you can't do this thing because you cannot approve a rejected order. Now, of course, ideally, I just wouldn't show that button to the user to say, well, you can't reject or you can't approve a rejected order, so I just wouldn't show that to the user. But I have this as kind of the last line of defense to make sure the state of my system is all good. So now that I've got my request, I've got the handler, I figured out how to make my handler cleaner based on refactoring and things like that, and I've modeled my response, the last thing is to say, okay, now I need to take that response and actually do something with it. And so I can actually lean on some of the prior art in terms of RESTful architecture to say, well, this right here is actually a representation of my information. So now I take that response and then transform it into a representation to the end user. So those representations could be HTML, it could be JSON, it could be a file on disk if I really wanted to go that. It could be whatever I want. One thing I do notice is that with a traditional MVC-style architecture, my controllers basically don't do anything anymore. They're delegating out to the handlers to do the actual work, but the code behind my controllers is basically doing nothing anymore. And so my controller is just a description of a route at this point. The MVC architecture looks at my controllers and actions to determine what the URLs are in my application. And so what this really is just a representation of routes that exist in my system. Now there's one thing new with ASP.NET Core known as Razor pages. And when I first saw that, I thought it was very similar to the old web form pages, which were horrible, but they're not that. They don't suck. They're not that bad. So these Razor pages is actually encapsulating the entire request into the view that needs to display it, as well as any back-end logic. So in this case, I've actually moved all of the requests, the responses, the handlers, everything into this one individual page object. And then everything I need to do to be able to handle this request is then separated out into these individual classes on this one Razor page object. So if you're using ASP.NET Core, this Razor page concept actually fits very, very well with this vertical slice architecture because it's removed this like God controller class that that has everything, all the requests in it, and instead we're plucking each of those requests out and placing them into these individual page objects instead. Now, if I'm not doing server-side HTML, which you probably still should be doing, I absolutely detest building single-page applications or spas. I find them very tedious to build. But if we are going that route, then and we're not going to have any kind of razor page behind the scenes, we'll still have that controller. So for those cases, I'm taking all the individual requests for each API call and representing them as individual handlers in my system. So to approve an order, there's going to be some kind of approve request. To reject, to put it placed on a hold, or to cancel it, I'll still have that controller because Web API makes me have that. But the actual logic to be able to perform that is then in each one of these handlers. Now, one thing that is different with spas versus regular web applications, typically in a web application, if I'm performing some action, like I'm approving an order or canceling an order, there's like some form comes up, I click the button, and then I get redirected back to the original screen. That's a little bit different for this one because each of these handlers, like, what are they returning? Are they just returning success, failure, or what's going on here? So what I usually find for single-page applications, there usually is actually a common response object because that response object represents that old flow of being able to post, redirect, and then finally getting out the original screen. So this is the case, that common response object is that response object that then gets bound to whatever SPA system I'm using, hopefully React, but if I'm unfortunate, maybe Angular. Now, there are cases in my system where I do have cross-cutting concerns. That is, I have duplication across all the kind of things going on in my system. Typically, that duplication is not really distinct or unique for each individual handler. It's basically that code I'm copying and pasting into each of my handlers. And so that usually is more domain agnostic or business logic agnostic. It's the thing I see, like, I'm just copying over and over again. And so what we wind up using for this case is another design pattern because, again, at C# we have to use objects. So in this case, we're using what's known as a pipeline behavior in Mediator, but it's also known as like the chain of responsibility pattern. A lot of different frameworks use something like this. You can kind of think of it similar to action filters and ASP.NET, but it's basically logic that executes around each of my handlers. And these can be stacked as well. So I can have an inner handler with a behavior around it, and finally the most outside behavior. So again, they're very, very similar to action filters. And what these look like is a wrapper around executing whatever inner handler or request is going on. So in this case, the signature is going to look a little bit different because I don't have the request and response initially. I'm passed in the request, but instead of me having the response as part of that, instead I have a delegate that says, okay, whenever you need to execute the next thing in the chain, then go ahead and call that delegate. So what do I typically use these kind of things for? One good example is to wrap all my handlers in transactions. So in this case, I've got a transaction behavior that wraps all of my handlers. And again, I'm passing in the request object, cancellation token because we have to do that in C#, and a delegate to execute the next action. So in this pipeline behavior, I begin the transaction. I then call whatever the next thing is in the line. So in this case, that's that line that says var response equals await next. I'm calling the next thing in the chain. And then finally, I'll go ahead and either commit the transaction and return the response, or if something goes wrong, then I will go ahead and roll back the transaction. With this pipeline behavior registered, I can make sure that every single request in my system is appropriately wrapped in a transaction. So I don't have to rely on like whatever magic behind the scenes that the ORMs do. It's very explicit and says this is the scope of each individual transaction. We can also do things like unit of work. So in this case, I was working with a system that had to do things in the database and send messages. And you can't transactionally do both of those things. So we used a unit of work to be able to capture all of those things they needed to do. And then when you completed the unit of work, it finally either committed the transaction or sent the messages out the door. I was on a project with MongoDB once. And MongoDB is horrible and should be used by no one. Because what we found is that we had to have a lot of retries as part of it because it would go down all the time. So in this case, I have a very simple retry logic that would say, I'm going to try to do this thing. In this case, like, oh no, this is Azure. Right, Azure is the one that always goes down. Yes. They explicitly tell you if you're using Azure SQL, you need to wrap it in retries because it will fail like every other time. So in this case, I have a very simple set of logic to retry an action. So in this case, I retry like 5 times or whatever it might be. And if I get some kind of error back from the client, then it says, okay, go ahead and if it's an error that we can't recover from, then just go ahead and fail. But if it's something we think we can recover again, go ahead and just retry that action again. Logging is another one. I can't mention like decorators without also showing logging. So in this case, I'm just logging, like I'm calling the thing, getting the thing back, and then, okay, I log the request and the response. Very exciting. Now, because we're using dependency injection, I do have to register these things with a container. So if I'm adding these different behaviors, I just register. In this case, I'm using ASP.NET Core. So I say, OK, find all the handlers, and then add the first behavior, which is transactions, and then add the second behavior, which is going to be logging. So for every single now request in my system, it will always be wrapped in a transaction and always have this logging applied to it. And I don't have to worry about my handlers knowing or caring about any of this behavioral logic going on. It's just automatically wrapped for everything. So again, this should look very, very similar to MVC action filters because the registration is a very similar kind of thing. So these behaviors get executed with every single handler, similar to action filters getting executed for all your requests. Now, one of the things I saw that actually does change a lot is my testing strategy with this kind of architecture. So if I'm looking at testing this kind of system where I have everything as requests, I have handler with all the real logic going on, and then finally responses, you look and say, well, what's the scope of what we're trying to test here? So a lot of folks look at trying to unit test to say like the most inner part of that logic, but I find that the kind of wider in scope my tests are, and the more it matches production, then the more confidence I have that if a test fails, that actually is a true failure and not just something weird going on behind the scenes. So looking at this, my typical tests are broken up into setup, execute, verify, or arrange, act, assert. So in this case, my arrange is just setting up the request object. The act is executing the handler pipeline, and then the assert is then asserting based on the response. Now, in my test, I want to reproduce as much as I can how production is actually set up. So in that case, I'm actually using dependency injection. I'm actually using the actual built application. I want to make my test harness as much as possible match how the real system actually behaves. Because what I don't want to have happen is a test pass, I go to use the application, and the application breaks. And the only way I can get the most confidence I can is to make my test as much as possible match the reality of what's going on in production. Now, there are test harnesses that come with ASP.NET Core and other web application frameworks. Now, those are a little too wide in scope for me because those are actually dealing with raw HTTP and raw HTML. That's a little too much for my tastes. I really just want to concern myself with the handler level. And so what I'll wind up doing is kind of mimicking what the application actually does. So in this case, I'll do things like make sure that every single time I execute a handler in a test, it's wrapped in some kind of scope. So in this case, you may not know about it, but every single request in an ASP.NET Core application is wrapped in some kind of scope. And so for my test, I'm going to have to reproduce that. So in this case, I'll be creating a scope every single time I want to do something in my tests. Setting up the tests data as well, I want to, again, use the real thing as much as possible. So in this case, what I'm doing is using the real ORM to set up test data. I'm not going to just set up test data in memory and then assume everything works in production. I actually want to push that information, that data, all the way down to the real database so that when my test executes, it's not going against some kind of fake in-memory thing that may or may not actually work in production. I want to make sure it's using the real stuff as much as possible. And the final thing I have to set up is then sending requests down and to whatever mediator behind the scenes. So in this case, in my controllers or in my page objects, I will do something like mediator.send. So what I'm doing here is creating that same kind of scope that would happen in a normal web request, and then calling send to make sure that matches as much as possible, again, what's going on in production. So my tests start to look something like this. In this case, I'm also using another C# feature known as using static, where I can say using static and then the type, and then I can use those methods as if they were declared in that. So instead of me calling like test helper.send, instead I could just call right there, await send async. I'm sending a request out, and then later on I'll go assert the response. You notice here I don't even know what the handler is. I don't care. I'm not testing the handler itself directly. What I'm really doing is saying I'm going to send this request like very similar to how it would work in production, and then based on the response, do those kinds of assertions. So testing queries becomes just as simple as testing the result. So in this case, what I'm doing is I'm creating a real object. I'm inserting it into the database. I'm sending the query down, and then in my assertions, I'm just asserting based off that result that came out the other side. Now in this case, it's inserting things directly. I usually try to avoid that. I usually try to set up through the front door as opposed to through the back door. That is, I want to use the same kind of request that a user would go through in order to set up the information in the system. So in this case, my setup is actually, in this case, creating a student. And I'm using the same command that the end user would use as if they're using the application to set up the information. So in this case, I'm completely ensuring that I don't set up data that is actually not possible in real life or in production. I'm using the exact same paths that the user would use to be able to set up the information. This used to happen to me quite a bit when I would set up all this test data manually, but it didn't actually match what could possibly happen in real life in production. So as much as possible, I try to use the actual paths the user would go through in order to set up the information in my system. But that's not always the case. Like there may not be like things that the user can set up or user can do themselves that's just set up behind the scenes, maybe just loading information some other way. So in that case, I will just fall back into inserting things directly. Now commands are a little bit more interesting because when I'm doing a command, I may not have all the things that I want to assert on that response. The response just may be, well, here's the ID of the thing that you affected, or here's nothing, because there's no response from the command type. So in those cases, when I execute the command, I want to have that full round trip to say, okay, now that that's completed successfully, I'm going to now open a new connection to the database and pull the information out and make sure that it matches what I expect. Now the reason why I'm doing this is because I want to, again, match as much as possible what the user does. So the user, when they're using the application, they're clicking buttons, they're going through screens, they're doing some stuff. And each one of those individual requests is, again, a completely encapsulated, isolated operation. So in my test, I want to match as much as possible what that user is doing. So if I'm imagining, like, how would I test this as a user, I would say, yes, go ahead and edit the student. I get redirected to the page for the student information, and I would read the page to make sure that all the things I changed match what I expect. And so that's effectively what this is doing for us. It's sending that command, full round trip, and then finally, once that's completed, pull that information back out and make sure it matches it appropriately. So that means that in our test, I wind up having a lot more integration tests initially, because my integration tests with full round trips to the database, very often many full round trips with each individual test, those are all scoped to the overall handler level. And then if I have my behavior pushed down into whatever domain model behind the scenes, the kind of like plain old objects, those are the places where I want to use unit tests. I'm not going to try to like mock things out or anything like that. I'm going to just rely on me pushing behavior down to be the place where I would actually do that unit test. So for these kinds of systems, I tend to have a little bit of a flip ratio of unit integration tests. Like the test pyramid or pie or whatever we have now says like 90% should be unit tests. And that's great, but like in a lot of my systems, 90% of the behavior is like not that interesting. And so I really want to test at this higher level. Now, when the behavior does get interesting, that is when I will push that behavior down into the domain model and test it, but not before it gets interesting. So in that actually isolated domain model is where I'll have my unit tests. Otherwise, majority of my system will be these integration tests. So some key takeaways. Vertical slices makes code really easy to add, change, and delete because each of those handlers and request objects are completely encapsulated from each other. And when I'm only ever adding code to my system, that means that I'm not breaking anything else. And one thing I want to make sure we don't do is we don't want to skip that refactor step. So after we code the dumbest thing that could possibly work in our handler, we still want to take that step back and say, like, is this good or not? Is this ugly? And then go ahead and say, OK, now we need to go ahead and refactor it. We want to push our behavior down as much as we can. So taking that code that was inside our handler, and if it gets complex, push it down into whatever domain model you're using when it gets complex, but not before. And the final thing is to make sure that we integration test our handlers and unit test the domain. So that is vertical slice architecture in a nutshell. So we want to prefer the celery style architecture, not the onion style architecture. No more of these concentric circle architectures anymore. So thank you very much. I'll be up here afterwards for questions. Otherwise, have a great rest of the conference. Thank you.